Hello everyone, so welcome back again, and today our topic is GRE Tunnel. Okay, so basically GRE Tunnel is the part of VPN. Okay, so in this GRE Tunnel, we creates a virtual point-to-point link. Let us assume this is our actual network in which R3 is connected to R8 via a link just like this. There are multiple paths can be there in reaching from R3 to R8. Okay. So in this, what we do, we create a GRE tunnel, a point-to-point virtual tunnel in between R3 and R8 by using the intermediate networks. And this network will behave like a direct link in between R3 and R8, and that is done by the help of some encapsulation method. Okay. So basically R3 and R8 will be directly connected via a virtual link. That virtual link, a virtual point-to-point link, is known as a GRE tunnel. Okay, a GRE tunnel used to connect two or more indirectly connected router via a virtual link. Okay, that is created via encapsulation and some processors behind that. Okay, so if I talk about a GRE tunnel, so GRE tunnel is a protocol used to encapsulate the various network layer protocols inside the point-to-point tunnel. Okay, it is mainly used to connect the remote networks over an intermediate network by forming a virtual point-to-point link between the two routers. So in between two different routers, we are creating a virtual point-to-point link by the help of GRE tunnel. Okay, so how the GRE tunnel works? So first of all, the encapsulation will be done. The encapsulation means adding some useful information with the existing packet. So we add another IP packet with a GRE header with the ongoing information. Then the tunneling will be done. Okay, the encapsulated packet will be sent over a normal networks with the tunneling phenomena. Then decapsulation will be done on the receiver end or the destination. So header will be removed at the destination end. Okay, this is how the GRE tunnel works. Now let's do the configuration over the GRE tunnel. Okay, dear. So let us assume we have a network just like this. In this network, let me explain you. This is our site number one, and this is our site number 2 and site number 3, and this is our intermediate ISP network. Okay, so what I want to do, I just want to create a tunnel in between R1 and R5. Okay, so for the tunnel, this will be my source IP address 200.0.0.2, and this will be my destination IP address. Okay, and this will be the tunnel IP address as source, and this is the tunnel destination. The virtual link will be set up, and this is my tunnel basically. Okay, so I just want to create a tunnel between R1 and R5, a virtual link in between these two virtual private network I want to set up in between these two. Okay, dear. So for that, first of all, I will do the routing because without routing, I can't able to do, I can't able to create the VPN tunnel. I cannot do the configuration of GRE without the reachability because I didn't have configured the routing. That is why R1 cannot able to ping R5. Let me try to do that. Let's go to router number 1 and try to communicate with R5. If I will ping R5 like 200.0.3.2, so it will not ping because I didn't have done the routing. So first of all, we have to perform the routing on this network. Okay, so let's do the routing. So go to global configuration mode. So we can do the routing with any dynamic routing protocol. For now, I will provide the reachability by the OSPF. I'm going to do the configuration of OSPF for the communication in between these devices. Okay, dear, these routers. Well, this is not necessary because this is not the part of VPN or GRE, but we can do the configuration over that also. Okay, so now I'll start the configuration with R1. Okay, so let's do the go to global configuration mode. Router OSPF1 network is what 200.0.0.0.0.0.255, area is 0. Okay, so we have just configured the OSPF on R1. Let's go to router number 2 and do the configuration of OSPF. So configuring terminal. Router OSPF1 network is what 200.0.0.0 and 0.0.0.255, area is 0. Network is what 200.0.1.0, 0.0.0.255, area is 0. So it will perform the neighborship with R1 soon after that. Okay, so you can wait for some time till the neighborship will be up. Now let's move to router number 3. Well, it will take some time to do that. Okay, so go to global configuration mode. So router OSPF1 network is what 200.0.1.0, 0.0.0.255, area is 0. Another network is what 200.0.4.0, 0.0.0.255, area is 0. Another network is 200.0.2.0, 0.0.0.255, area is 0. Okay, let's go to router number 4 and do the configuration of OSPF. How can we do that? Go to global configuration mode. Router OSPF1 network is what 200.0.2.0, 0.0.0.255, area 0. Okay, and network is what 200.0.3.0, 0.0.0.255, area 0. Okay, let's go to router number 5 and do the configuration of OSPF. Go to global configuration mode. Router OSPF1 network is what 200.0.3.0, 0.0.0.255, area 0. Okay, let's go to router number 7 and do the configuration. Okay, so go to global configuration mode. Router OSPF 1 network is what 200.0.4.0, 0.0.0.255, area 0. Network is 200.0.5.0, 0.0.0.255, area 0. Okay, so the decencies are up now. Let's go to router number 6 and do the configuration. Here we got router number 6. Go to global configuration mode. Router OSPF1 network is what 200.0.5.0, 0.0.0.255, area 0. Okay, so we have done the configuration of OSPF everywhere. Okay, dear. So let me try to ping again. Ping R1 with R3 after doing the configuration. So after doing the configuration of OSPF, let me try to ping R1 and R5 with these IP addresses. I need to uh, communicate via these physical interface IP addresses like 200.0.0.2 and 200.0.3.2 because we will create the tunnel on the behalf of these IP addresses. So now let me come try to communicate in between these to check the reachability. Okay, so ping that is 200.0.3.2 and it's pinging perfectly, right? So that it means data can be forwarded in between these. Okay, now let's we can create the tunnel in between R1 and R4 R5. So if I talk about tunnel in between R1 and R5, this will be the source IP address for the tunnel and this will be the destination IP address when I will do the configuration on R1. This will become the source and this will become the destination of tunnel. And this is the virtual IP address of the tunnel source and this is the virtual IP address for tunnel destination because after the configuration of tunneling this there will be a separate path and that path must have any IP addresses. So that is why we have to provide this IP address. Okay, and this is the network belong to this private IP Now let's start doing the configuration of GRE tunnel on R1. Okay, so let's go to router number one, go to global configuration mode, interface tunnel one. We can randomly give uh, any name to this tunnel. Okay, so tunnel source is 200.0.0.2. Okay, and the tunnel destination is 200.0.3.2. Okay, and the IP address of this tunnel is 192.168.10.1 and 255.255.255.0. So we have done the configuration of tunnel on this interface on R1. Okay, let's go to router number 5 and do the configuration of tunnel. So go to global configuration mode, interface tunnel 1. Let's create a tunnel 1. Okay, on this we have tunnel source is, that is 200.0.3.2. For R5, the tunnel source will be this IP address. The physical interface IP address will become the tunnel source. And here we got the destination of this tunnel. So this will be the source and this will be the destination. And this will be the network in between them. This is the source IP address. This is the tunnel interface IP. Let's provide all these details. Okay. Tunnel destination, that is 200.0.0.2. Okay, and IP address will be 192.168.10.2 and 255.255.0. But the problem is that the tunnel is down. What? There is no message of tunneling in between them. So the tunnel is down. Why? Because we didn't have created the neighborship in between these two. To create the neighborship in between these two, we have to do the configuration of routing in between these two. How we can do the routing? We can use the OSPF or EIGRP. So currently I'm going to use the EIGRP for the neighborship in between the tunnel interfaces. Okay, so let's go to router number 1 and do the configuration of tunnel, configuration of EIGRP. So router EIGRP1 network, that is 192.168.10.0. Okay, another network we have to define, because both of these are available on router number 1. So we have to define both network, this loopback network as well as the network belong to our interface. And on R5 we also have to mention this network as well as this uh, tunnel network to create the neighborship. Okay, so network 10.0.1.0. Okay, we have defined the network on EIGRP. Let's go to router number 5 and also do the same. Okay, so router EIGRP1 network is 10.0.2.0 and another network is 192.168.10.01. Once we will do the configuration, now we got the neighborship message of the tunnel IP addresses. Okay. Okay, now we have just created a tunnel in between R1 and R5, and let me try to ping this IP address from this IP address. Let's try to ping the LAN interfaces of the routers. This is the LAN interfaces for R1 and this is the LAN interface for R5. So let me try to ping these two. If they will ping, so the tunnel is successfully working. If they are not pinging, so tunnel is not working. Okay, let's go to router number 1 and try to ping these. So ping, that is 10.0.2.1 via source 10.0.1.1, and that is pinging perfectly. That is means our tunnel is working perfectly. So this is how the GRE tunnel works, the configuration of GRE tunnel. Okay, and if you want to check the statistics for the same, show interface tunnel. So by the help of tunnel 1, sorry, here we can see that the tunnel is working and tunnel is up now, and this is the bandwidth for the same 100 KB per second and so on. Okay, this is the source of the tunnel, this is the destination of the tunnel, and this is GRE type of tunnel. MTU size is 1476, that is lesser than 1500. So this is all what we got in the tunnel, and that is working perfectly. So dear, this is how you can configure the tunnel on the basis of GRE. This is how you can do the configuration VPN by the help of GRE tunnel. And I hope you like the session. Have a nice day.